Welcome to my channel. Today I will just discuss the introduction to bode plot. So bode plot is a frequency response plot of sinusoidal transfer function. So sinusoidal transfer function is represented by g of j omega for any system. So bode plot consists of two graphs. One is a plot of magnitude, okay, of a sinusoidal transfer function versus log omega. And other plot is the plot of phase angle of a sinusoidal transfer function versus log omega. Bode plot can be drawn for both open loop as well as closed loop systems. Okay, so usually bode plot is drawn for open loop system. The standard representation of logarithmic magnitude of open loop transfer function of this sinusoidal transfer function is 20 log magnitude of g of j omega, where the base of this log is 10. So the unit used in this representation of the magnitude is in decibels, usually abbreviated as dB. So the curves are drawn on semilog graph sheet using the log scale for frequency and linear scale for either magnitude or for phase angle. So magnitude is represented in decibels and phase angle is considered in degrees. The main advantage of bode plot is that multiplication of the magnitudes can be converted into addition. So let us consider an open loop transfer function. G of s is equal to k into 1 plus st1 divided by s into 1 plus st2 into 1 plus st3. Now this is our g of s. Let us convert that into sinusoidal form. Simply we have to replace s by j omega to convert g of s into g of j omega. Means to convert open loop transfer function, which is in S domain, to sinusoidal transfer function, what we have to do is simply replace S by j omega. So here we have, wherever S is there in the open loop transfer function, there you have to replace it by j omega, then it becomes a sinusoidal transfer function. So g of j omega is equal to k into 1 plus j omega t1 divided by j omega into 1 plus j omega t2 into 1 plus j omega t3. Now if you observe carefully, this term is in rectangular form, this term is in rectangular form, this is also in rectangular form. Okay, and if you have rectangular form terms, you can convert them into polar form. So that's what I have done here. K is a constant, so I have converted all these rectangular forms into polar. So here j omega is there, so you can write real part is not there. Okay, so real part you can assume it as 0 plus j omega. So when I convert this is a constant, so k at an angle of 0 degrees in polar form. So polar form of 1 plus j omega t1 is root of 1 square plus omega square t1 square at an angle of tan inverse of omega t1 by 1. And divided by j omega is there. So polar form of j omega is omega at an angle of 90 degree. And 1 plus j omega t2, its polar form is 1 square plus root of 1 square plus omega square t square at an angle of tan inverse of omega t2, okay, divided by 1. And polar form of 1 plus j omega t3 is root of 1 square plus omega square t3 square at an angle of tan inverse of omega t3 by 1. Okay, so magnitudes, here we have angles and magnitudes. We can separate the magnitudes and we can write them as magnitude of g of j omega is k into root of 1 plus omega square t1 square divided by omega into root of 1 plus omega square t2 square into root of 1 plus omega square t3 square. And the phase angle of g of j omega, that is angle g of j omega, is phase angles are 0 degree plus tan inverse of omega t1 minus 90. Minus 90, why? Because this 90 is in the denominator, I have sent it to the numerator, so it has become minus 90. Similarly, in the denominator you can see tan inverse of omega t2 is there, you send it to the numerator, it will become minus tan inverse of omega t2. And similarly, this tan inverse of omega t3 is in the denominator, send it to the numerator, it will become minus tan inverse of omega t3. Okay, now If I want the magnitude of g of j omega in decibels, so you can rewrite in decibels as 20 log of g of j omega. So if you write it this g of j omega in terms of decibels, that is 20 log of g of j omega. So you can write it as 20 log k root of 1 plus omega square t1 square divided by omega root of 1 plus omega square t2 square root of 1 plus omega square t3 square. Okay. Now I have split all these terms. Okay, and I have simply expanded this whole expression here in the next expression, that is I have written it as 20 log k by omega into root of 1 plus omega square t1 square into 1 by omega 1 by root of 1 plus omega square t2 square into 1 by root of 1 plus omega square t3 square. Okay, so and I have this 20 log I have sent inside, and I have multiplied this 20 log with each and every term. If you multiply, what will happen is this whole expression will convert into 20 log k by omega plus 20 log root of 1 plus omega square t1 square plus 20 log 1 by root of 1 plus omega square t2 square plus 20 log 1 by root of 1 plus omega square t3 square. So if these denominator terms, if you want to send them to the numerator, you can send them. When denominator terms goes to the numerator, instead of plus you must write minus here. Instead of plus you must write minus here. Okay, so this is our magnitude equation. Okay, so by looking at this equation, we can say that the magnitude expression which we have written here is in decibel, and the multiplication is converted into what? Addition, isn't it? If you observe carefully, here I have written multiplication symbol, so that multiplication symbol is converted into addition here. Okay, so hence in magnitude plot, the decibel magnitudes of individual factor of g of j omega can be added. Okay, therefore, to sketch the magnitude plot, a knowledge of magnitude variation of individual factor is essential. Okay, so this is the introduction to bode plot. Thank you for watching my channel.